Hello.
Hello.
Hello, everybody.
Hello, everybody. I'm together with my colleague.
Hello. And I'm together with Amod, and we have the pleasure to show you today the powerful solution we have in 5X simultaneous in SolidCAM.
Great. So, Wolfgang, I'll start, and then I'll hand over the stage to you. Thank you very much. So today we are going to do two types of presentation. One, I'm going to present myself, my part in 5-axis, and Wolfgang is also going to present his part in 5-axis, where he's going to talk about this particular part on how he did it on NTX 500. So my presentation has got two parts. I'm going to explain to you why we need simultaneous 5-axis, why SolidCAM simultaneous 5-axis is needed. So first of all, we have got excellent toolpath strategies. We have got comprehensive collision avoidance system where we can take care of any kind of collisions that are coming, and we can remove those collisions and give a collision-free toolpath to the user. And sophisticated tool axis control, because it's not a straightforward tool axis control, it's a sophisticated tool axis control. It's a proven technology. It's been around in SolidCAM for the last 2 decades, so it's a long, long time. And we have got excellent realistic machine simulation that simulates the entire part, including the material removal. So when I say we have a comprehensive offering, we have got several things that constitute SolidCAM's 5-axis. The generic 5-axis, the multi-axis machining, which includes roughing and finishing, multi-blade machining, port machining, rotary machining, edge braking, edge trimming, auto 3+2 roughing, and finally, in 2024 SP2, we still have it in the beta, but you can use it because it's very, very robust and reliable. We have as the 5-axis milling of Pro 3D HSM. It's still called as Turbo, but we'll soon have the name change of this particular technology. I'm going to run quickly through the first few slides, primarily because I've covered this in several of my webinars and everybody knows about it. But I'm going to talk to you about a very important project that we did with Kennametal. And it was one of the most important projects even in my career that I did, because a lot of things I learned from that project. And I'm going to present to you that particular technology. It's kind of a technological cooperation. So I'm going to run quickly with the generic 5-axis. It's a perfect solution for any 5-axis machining. You can machine the part the way you like it. You also features user-defined collision check, smooth lead-in and lead-out for all standard tools, including the circle end mills. And then we go on to the rotary finishing, which is meant for finishing of cylindrical parts. You can directly calculate the tool path on a 3D model. Along and around strategies are available. Tool contact point can easily be modified. Swerve machining, very robust engine for machining walls, basically prismatic parts in 4, 5, and 3-axis. Clean results, most of the time they are burr-free results. Automatic tilt control, and it has got a very high demand. Any company in the world will always need swerve machining as far as 5-axis is concerned. So moving on next, the 3 to 5-axis conversion. This is more for die and mold components or areas which are very hard to reach. You generate a 3-axis tool path, and it automatically tilts the tool to give you a 5-axis output, allowing you to use very short tools to go deep into a particular region. Because of the short tool nature, we get excellent surface quality, and there's a reduced risk of tool breakage. Multi-axis drilling, again, for drilling from different directions automatically, you can create the drilling paths in full 5-axis. Tilting, linking, and collision avoidance are already built into the drilling system. The drill depth is automatically controlled by the software, and it's a very powerful tool to improve your efficiency and productivity. And there is no special expertise needed. The training time is bare minimum. Contour 5-axis machine, this is for deburring of the edges, and it's more of a manual process where no surface definitions are needed. It's a very robust engine. Tool orientation is done by tilt lines. It supports different types of tools, ball, bull, end mill, chamfers, anything. Geodesic machining, it's a new generation pattern generator. Basically, it's just a pattern generator. It doesn't do anything with the tool axis and all. We still use the same tool axis control of our generic 5-axis. And the step over that is generated is constant, irrespective of from which direction you look at it. And it works both on the mesh data as well as surface groups. Auto 3+2 roughing creates automatic 3+2 roughing programs from different directions, and can be done in automatic, manual, as well as semi-automatic way. Circle end mill support. We are supporting barrel tools since 2019. More and more tool manufacturers today are producing these tools, pushing them into the market, and claiming that they save up to 90% of the time as far as machining time is concerned. And that's primarily because of their large radius, big step over, still allowing you to get the same scallop. So we support all the 4 shapes that are shown. Multi-axis machining, again, this comprises of 2 things, the roughing as well as finishing of pocket-shaped geometries in 5-axis. It's very simple to work with. You just have to specify the floor and the wall, and the tool paths are generated automatically. Adaptive roughing feature is also available, which looks very similar to eye machining. The wall and floor finishing utilize the new generation circle end mills, which is the barrel, oval, taper, and the lens form. Okay, that's about the wall finishing. Just talked about it. Moving on to multi-blade machining. This is for impellers, where it's a very powerful machine. It's a machining engine for impellers and blisks. It's a classic impeller with splitters. That's a classic application. Minimum inputs, automatic tool axis control. Root fillets are handled with ease, and more often it generates a tool path very quickly. And there are separate machining strategies for roughing, blade finishing, floor finishing, and fillet finishing. Port, again, for tube-shaped geometries. This is, again, a machining engine for tube-shaped geometries. Like multi-blade, minimum inputs, very powerful automatic tool axis control, roughing, rest roughing, spiral finishing, and plunge finishing strategies are available. Rotary machining, this is, again, for cylindrical components where you can do roughing as well as finishing when it's rotating around the 4th axis. It's a very powerful functionality. The roughing is based on Pro 3D HSM. Only thing, the difference between Pro 3D HSM and rotary is that in Pro 3D HSM, the slicing is done using planes, while in rotary, the slicing is done using cylindrical space. So we support all the standard tools, and the user just selects the part, stock, depth of cut, side step. Everything else is done by the software. Edge braking, I've talked a lot about this. This is one particular module that every shop floor in the world will need it, irrespective of what kind of part they're doing. Edge braking is something that everybody needs. So it's an automatic functionality that generates deburring toolpath in 3-axis, 4-axis, 4+1, 5 minimum tilting, and 5 full axis. And currently, this is a very manual process. A lot of people are employed for it. And the edge braking now, the automatic edge braking removes all that particular manual edge braking or manual deburring that is done and brings the mathematical deburring directly on the machine. Edge trimming, it's for trimming of vacuum form parts or composites. It's a very highly automated algorithm for composites and other components. The trimming edge can be automatically defined, and the position is relative to the geometry, and there are various options to define the position of the tool. I'll come to Turbo 5-axis. I'll spend some time on this because this is something new that we released in 2024 SP2, but like I said, it's still in beta because I want more and more people to use it and come back with me with issues. This is it's Pro 3D HSM, and the generation happens in 5-axis. So you have got constant Z rest machining. You have got linear machining, constant step-over machining, rest machining, all of these functionalities working in the 5-axis space. So generation itself directly happens in 5-axis. So it's a proven engine. It works on the Pro3D HSM engine, and simultaneous 5-axis toolpath controls options are just added, and that's more or less an automatic option of tilting the tool. It's completely automated. There is nothing that the user really needs to do. Of course, there is some tweaks that the user is allowed to do. It's an excellent solution for machining molds and dies. Okay, you can try this. We have added another functionality to this turbo 5-axis, and it is available in the undercut machining. It's called as 5-axis undercut milling, wherein you can use that particular functionality to machine any component. It doesn't matter if it's a die mold component or an aerospace component or a medical component. All the tilting and everything is done automatically by the software. You don't need to define what it needs to do. So it's a very, very powerful functionality. So it's a combination of two functionalities. Shortest learning curve, hardly a few hours of training, and you're up and running on the job. And it's a very robust and reliable engine. So I did some research using some AI functions because I hate to use Google these days. So I used AI to ask what is happening, what is the chatter that is going around on the internet about good and bad things about SolidCAM. So I brought some good things about SolidCAM, and I want to show you that. First of all, people are talking about the ease of use and flexibility of the product, especially in 5-axis. So they are talking a lot. There's a lot of chatter about this particular functionality. We have advanced toolpath control. A lot of our competitors, users are speaking about this. Okay, most of them are using our most commonly used softwares. We have a very good collision avoidance systems. This has come mainly from the Autodesk users. This is what the AI system told me. And we have very strong simulation capabilities. Again, this is coming from our competition, not that I have written it. Okay, in the summary, we have a very complete, powerful solution to machine any part. It's a most tested and proven 5-axis engine. Easy to learn with a very user-friendly GUI, complete control on the entire toolpath aspect, complete control over toolpath collision avoidance system, and application-specific strategies, including edge deburring, turbo 5-axis. They all complete the offerings that we have. So overall, we have a very powerful product. Now, this is what I am telling you. If I go and tell my customer this, that I have a very powerful product, he's not going to believe me unless and until he doesn't see this happening on his own part and own machine. So what we did was there was some kind of a initiative taken up by Kennametal. And Kennametal wanted to work with us to find out a solution or a replacement for their existing strategy in which they use Sim5X and their tools and their process to machine an IBR. An IBR is nothing but a integral blade rotor, okay? Now I'll come and tell you what this integral blade rotor is. So what's an integral blade rotor? I mean, everybody would have flown into Munich. So when you look out of your engines, you see the big engine, and you see, first of all, some discs outside. So that's the first integral blade rotor that you see outside on your engine, on that part. Now, there are many such rotors within the engine. I counted about at least 18 rotors within that engine. Okay, so it's also known as a blisk or a bladed disc, and it's a very critical part in the turbo machinery, particularly in the gas turbine engines. It's characterized by integration of the blade and the rotor. So everything is one, fused into one. No longer it is an element that is separate. And this design eliminates the need for having a separate removable blade, which actually reduces the efficiency of the engine itself. That's why this integration happens. And it's typically manufactured from high-strength super alloys, and it's machined using 5-axis. So that's the typical engine. Like I said, I counted there are about 18 different IBRs on this particular engine itself. Depending on the size, it could be more or less. So the industrial application, first, they are used in aerospace industries by both military as well as commercial airlines. Power generation, it's there also in marine propulsion, and it's there also in industrial turbo machinery like pumps and compressors. So, it's a very big market, okay? And the estimated size of this market of machining this particular integral blade rotor is approximately $19.6 billion in 2022, and it is going to touch about $30 billion in 2025. I think it's 2030, sorry. And it's growing at the rate of almost at 9% with the kind of aircrafts. If anybody is having internet, just open flightradar24.com and look at the map of the world, and you'll see thousands of aircrafts flying at any given time. So all of them use the IBRs. So who is the four main players in machining of this particular IBRs? First one, Sim5X. Second one, Dassault CATIA. Everybody will be thinking, why CATIA? CATIA is being used. Let's accept it. The third one, which is also very popular, is NREC MaxPack, which is a very dedicated solution for turbo machinery. And the fourth one is OpenMind Hypermill. So these are four players that are eating away this $19.6 billion pie that is there in the IBR market. Where is SolidCAM? Nowhere. We're not there in this market. Okay? This is a huge market. Huge, huge, beyond our imagination. It's a huge market. And products like Hypermill and NREC MaxPack, they have a niche products just for this particular application. Okay? We are still not there. But machining an IBR is not a straightforward thing. It's not that you just create a toolpath, you go on the machine, it runs, it will not run. There are several challenges. Complex geometries, material is hard, deflection during machining because each IBR is not more than a millimeter or millimeter and a half thick, so there's a deflection. Cost implications, it's very high. Each IBR costs anywhere between $30,000 to $40,000, so a slight mistake can scrap the entire IBR because it's an integral one. It's not those blades that are assembled. Furthermore, there is surface roughness. That means you need to have a very smooth surface. That's another challenge. Waviness and deflection, tool wear and material removal, and surface integrity issues. These are all the challenges that are there in the IBR machining. So, what we learned from Kennametal. I still remember, quickly I'll give you in 10-20 seconds. We had a meeting with Kennametal with Avishai. Where are you, Avishai? There he is. So we had a meeting with Avishai. We had a meeting with one of their chief technologists, Yossi, who sits in Israel, and their NX programmer. And they were explaining to me how an IBR is to be machined. And they were trying to find out whether it can be done in SolidCAM. So I had two screens. On one screen, I was listening to them and looking at them. On the second screen, I opened a very similar looking part like what they were showing me, and I started programming them as they were telling me the process. So when the meeting was over, they asked me, did you understand the process? I said, can I show you my screen? And I showed them that in the time they explained me the process, I had already created that process on SolidCAM. It's that easy to work with SolidCAM in 5-axis. Although it looks huge, but it's very simple to work with SolidCAM in 5-axis, okay? So, like I said, Kennametal has already done this process. They have finalized, fixed this process both with NX and CATIA, and they had issues with both of them, working with them. Although it's working, but there are challenges. Constructing an entire geometry in NX and CATIA is not an easy job. They need to do that. Tool-axis control in multi-axis operations is very, very difficult in NX and CATIA. And there is limited multi-axis strategies both in NX and CATIA. And then the user interface challenge comes up, and limited collision checking capabilities. So, with SolidCAM, what we did, I don't want to run this because this is the same slide that I showed you before. But I would like to show you what we did with Kennametal and what makes SolidCAM special. Consistent tool engagement, this is what we found on the entire part. Minimize tool path deviations. Backplotting for visual SimCook turns out to be a great savior here. With the new version, you can do the material cutting simulation, and there is enhanced simulation capabilities. Actually, I'm going to do a webinar on this when I get back because it's a very vast subject. We spent months together on this particular area here. So if you look at the part that we did it on a titanium 6 ALV. It's a titanium alloy. The machine was a DMU 65 monoblock, number of blades 55. The blade height was 60 mm. The thickness of the blade 1.5 millimeter with the end radius of 0.2 millimeter. And the diameter of the IBR was 778 mm. We just took a portion of that to machine it. And this is the blade, 60 mm. With, if I zoom in further, it's about 1.9 millimeter at the thickest section of the blade and 0.2 millimeter fillet at the end. So it's a very complex one, and this is how we did this process. Was supplied to me by Kennametal. So we started with the single slot roughing, and then we moved on to semi-finishing the aerofoil. On the very first level, we did not go all the way down. We just went level by level. We did the roughing, semi-finishing, and finishing. Okay, so we used all these methods to machine this entire part. So that's all the 3 levels in one go. Okay. And that's the cutting time for each of these levels. So what, in the end, we noticed, Wolfgang, I'll just take one more minute and I'm done. What we noticed in the end of this entire exercise was the strategies that use ball nose are far more efficient than the strategies that use barrel mills. Because all of their competitors were using barrel mills to machine it, and barrel mill actually slows down the machining of such parts. Like I've always believed that barrel mill is not a tool that can be used anywhere. It also has its own limitations. Okay? So in this particular case, because the barrel mill has got a very large surface area when it comes in contact with the blade, it can deflect the blade when it is machining. So it's not something that can be used on this particular part. And here the ball nose becomes very, very important. So like I said, I'm going to make a complete webinar on this entire subject of IBRs. It's a very vast one. In fact, I've tried to compress what we did as a solution with Kennametal into few slides. So the summary is, we have very good tool path strategies for IBR. We have excellent collision avoidance, realistic machine simulation, robust and reliable post-processors. We were going on the machine on the very first attempt, no changes on the G-code. And finally, with the SimCook integration, like I said, is a savior for us. We can do material simulation and comparison of the part once the part is done. Right, I'm going to hand over the stage to Wolfgang. Wolfgang, sorry. Here.
Thank you very much,
Thank you.
Amod. Okay. Thank you for the deep insights in the IBR machining and the cooperation with Kennametal. I want to talk about a little bit about SolidCAM.
One second.
Yeah.
Okay, I'd just like to thank Amod for the nice presentation. I would like to tell everybody in the room from the different country, I committed that if you have any customer produce IBR or any kind of airfoil milling against any kind of software 5-axis, that any project that exists, I commit at least to reduce cycle time with SolidCAM at least 25 to 30%, and it's in this case is hours, is days of saving. If one of you have any opportunity, contact with Amod, and we can join together and go into the project.
Okay, now it's my turn. I think I have a little bit to hurry because I only have 5 minutes left. But what I want to tell you, why SolidCAM offers one of the best 5-axis simultaneous solution in the whole CAM market. I come to the conclusion there are 5 major topics why we are the best. First, Emil also mentioned it, we are fully and seamlessly integrated in the CAD system. Not only one, it's 4 at the moment and getting more and more. The second point, we have powerful strategies and an easy to use interface. The third one is the technical stuff we have at SolidCAM. We have highly skilled employees with practical background who can offer solutions to the customer. Fourth things, post-processors. One major advantage is all post-processors on machine simulations are done by ourselves, and we are very flexible and can quickly create posts for any kind of machines. And the fifth one, we have excellent partnerships with the whole industry, with the strongest technology partners in the industry. Okay, now I want to talk about why I think this is a major advantage with the CAD system. We have a fully grown CAD system in the background. You know, when you mill some parts, you always have issues. You don't have perfect parts you want to mill. And with a CAD system in the background, it's really easy to use to fix such things, to patch up surfaces, patch up holes in a couple of clicks. I think that's a very, very big advantage. And it's easy in SolidWorks, it's easy in Inventor, it's easy in Solid Edge. In all our CAD systems, we are seamlessly integrated. Powerful strategies and easy to use interface. When I begin at SolidCAM, we only have 3 solutions for 5X simultaneous. That was HSM to 5X conversion, multi-axis drilling, and 5X generic simultaneous. Now with the SolidCAM 2024, we have over 15 strategies for any kind of parts, and I think we can machine any part we want. Okay, what's also easy to use interface. When you program with SolidCAM, there are always 3 steps you have to take to get a toolpath. First, define your toolpath, define your geometry. Second, you have to define your tool. And third one is set up your parameters. It's always the same. It doesn't matter which job do you use in SolidCAM, you always have to define these 3 steps. For the complexity of the 5X simultaneous as it is, you have to do 2 additional steps. One is define your tilting, how you want to engage your part or approach your part. And the last thing is collision checking. But with the example of geodesic operation, you can do in a couple of clicks 5X simultaneous, collision-free toolpath. You can run on the machine without any to get in any trouble. Okay, last one, collision control. I always take the automatic tilting. It's perfect. Okay, one major advantage I also want to mention is we have highly skilled technical staff. Nobody was born as an expert. Look at me at a young age. I didn't know how to properly use shoe cream. But with training, experience, thirst of knowledge, dedication, trying, and also failure or mistakes, you grow to an expert. And that I can say to any technical staff, to any employee in SolidCAM, They are all experts. I know we have the 40-year anniversary for SolidCAM, but in my opinion, the knowledge from the SolidCAM employees is far more than 40 years of experience. Okay, fourth thing, it's also, SolidCAM has the best technical stuff in the market, and with that knowledge, we can have a solution for every customer. So, next thing, post-processor. Post-processor is a main advantage because it's done by ourselves. We don't have to go to a third party like other CAM systems, and that makes us very flexible. We also have very high qualified post-processor guys. Look, the guys in Serbia are perfect at that, what they're doing, and they can manage any kind of CNC controller. For example, we set up the AMB machine. It was a CTX 450. It's the serial number 2. It was a prototype machine. Ronnie sent me a post, and it works. Works first time. Okay. Excellent partnerships with the best technology partners in the industry. I think it speaks for itself. Everybody wants to cooperate with SolidCAM. Also, Michael mentioned it, in his lecture, and I think take these partnerships, find a solution for your customer. It's a game changer. If you have a complete solution for the customer, use it. Yeah. One thing I try to hurry up a little bit is the part Michael always mentioned. It shows us what we can achieve with such a strong software and such a good cooperation. The Lada Manufaktur is a company in the north of Germany. They do power enhancing car tuning parts. And they come up to us and ask us if we can help them to mill a complicated part. This was the part they want to mill, and they want to do it from a full aluminum body. Yeah. Okay. This part is for a car of a German car tuner. It's called JP Performance. He's a very famous car tuner, and he wants to build up this Volkswagen Golf 2 with 1,000 horsepower. JP Performance is very influential in the social media. He has 2.6 million followers on YouTube, almost the same on Instagram, and this is a big marketing for us. So, Michael found this part so excited. He talked to me and said, hey, can we do it on the AB exhibition to 2024 on a CTX 450 TC. It's a mill turn machine, and 80% of this part are milling operations. Yeah, that's the part. And we did it on this kind of machine. As I mentioned, it was the second serial number 2 of this machine. It was a prototype. It was a world premiere. We had this machine on our booth. And the people liked it very much. We started with a stock material of 15 kilograms, and this around about 1.5 kilograms was left from the part. That was the first step, but for the Thunder Bunny, we need something more special. And Michael came with the idea to mill this part. This is the original version they put in the Thunder Bunny and show it on the SEMA in Las Vegas. It's a big car show in November. Yeah, I also have a little bit of video, but I think it doesn't work. Yeah, it's a little bit round up how I milled the whole part in Alzmetall. It was a very beautiful part because we have every kind of operation in this part. It took me around about 6 hours to mill the whole part, and yeah, the part in the end was perfect. Yeah, I skipped it. Okay, and also on the AMB, we give them to the Lademanufaktur. This is the final part, this is the final product. They build up in the car, they also will be gold coated, and as I told you, in Las Vegas, you can see this car with our milled turbocharger housings. And this last phrase I like very much. Everyone knew it was impossible until a fool who didn't know came along and did it. And I think with our solution, we can handle everything. That's for me. Thanks for your attention. Thank you.